Welcome to the HL7 Open Source Tooling series. Today we welcome David Otasek, who is a software developer for Smile Digital Health. David does development work and maintenance work for the FHIR core libraries alongside the FHIR management group. He will be sharing with you the FHIR Validator, hopefully an in-depth view into this tool that you can use, and we'll take questions at the end of the session. Please put any questions that you have in the Q&A box or the chat, and we will get to as many as possible when David wraps up. Welcome, David.
Thank you, Sandy, and thanks, Mel, for being in the background and giving technical assistance. I'm David Otasek. I'm a software developer at Smile Digital Health. I assist Graham Grieve in developing and maintaining a variety of tools used in the FHIR community. I have 3 years of experience with FHIR, so I'm still relatively new to it, at least in context of all the people I work with. And in a previous life, I developed data visualization software for bioinformatics research. As with all things on FHIR, this is documented in detail in the FHIR specification itself. This is always a good reference point, and we'll walk through some of the major points of it. On a high level, validation is a logical process that uses the conformance resources I mentioned earlier within the FHIR implementation guides and the FHIR specification to decide what constitutes a valid resource in a specific FHIR context. We can break down the validation process into 7 aspects of a resource we can logically check: structure, cardinality, value domains, coding and codable concept bindings, invariants, profiles, and questionnaires. Technically, business rules constitute the 8th aspect. However, those rules exist outside of the scope of just the data in a resource. For example, you would not check for duplicate resources or verify the authorization of a specific user. All that is outside of the scope of a single resource. So to be valid, any given resource must satisfy all of these listed aspects. If it does so, it is valid in the context of the FHIR specification. Now we can go back to a resource specification, like patient, which is shown here, and we have a better idea of what to look for. Every resource will have a resource content section in which you will find a structure table. That's shown here. That table is an excellent place to orient yourself with the basic properties of that resource. The resource specification as a whole will contain all the necessary information to check the aspects I mentioned. Navigating these specifications is a fundamental skill in FHIR validation. Let's look at how we can validate each of these aspects for ourselves. Structure. To validate structure, we're ensuring that the properties contained in the resource are those expected by the specification. There should be no unspecified properties. You can find names for expected properties in the name column of the structure table. I've highlighted the active property, the name property, and the telecom property. If a property such as favorite color exists in a patient resource, it's violating the structural validity of that resource. You will not find an entry for it in the structure table. That's what produced our error earlier. Cardinality. Cardinality is the number of times that a property can appear in a FHIR resource. You can find the cardinality for each property of a resource in the card column. Card is just an abbreviation of cardinality. If a property appears too many or too few times, it will make the resource invalid. If we look at the active property, for example, you can see that it should occur 0 or 1 times, as indicated by the 0 and the 1 separated by 2 dots. In the description and constraints column, we can see that the active property describes whether or not this patient's record is in active use. If the property occurs 0 times, it is unknown to us. If it is known, it should only occur once. It would create ambiguity if multiple true and false entries existed. Sorry, give me just a moment. All right. All right, where was I? Sorry, in contrast to active, we have an example of a field with multiple cardinality, which is the address property. Patients may not have an address, or they may have several, as indicated by the asterisk symbol. Value domain. To be valid, each property must be of a type defined by the specification. You can find this listed in the type column of the structure table. A type can be primitive, like the Boolean true and false of the active property, or it can be complex, like the identifier data type. Each property will have a type, and when you browse the specification, you can navigate to that type definition. If we follow the identifier link from the patient resource specification, we will find the definition for identifier. The identifier type specification will then provide the validator with its own conformance information to evaluate. I'm going to take a deep breath here because this next section, it takes a little bit to get through, but we'll get through it. The next aspect of validation is coding and codable concept bindings. I'm going to do an in-depth look into codes and codable concepts, but I'm not going to go too deep because that's a presentation all unto its own, but I will try to give you some basic understanding. Code and codable concepts are types where the value of a property is a specific sequence of characters that has meaning defined elsewhere, normally in a code system. Code systems can be internal, meaning they are defined within the FHIR specification itself, or they can be external and maintained by another organization. Here's an example of an internal code system. You can see the code system specified in the system field. Systems are specified by a unique URI, in this case, hl7.org/FHIR/account status. The code itself, specified by the code field, is active, lowercase, and a display value for the code is included, which is also active. If we look up that code system using that URI, we can see that the full definition of active is that this account is active and may be used. So that's what we mentioned earlier. There's a code which is active and an actual definition attached to that code. External systems are also commonly used in FHIR. There are roughly a dozen of these that are used in the base specification. Two that you will find referenced quite often are SNOMED and LOINC. This is an example from SNOMED. You can see the URI for the code system. You can also see a unique numeric code, which actually doesn't tell us a great deal. But you can also see a helpful display value, which is negative, which is intended for human consumption. And then you can see the actual value from SNOMED listed to the right-hand side, and that is the external system I'm talking about. Unlike the relatively manageable account status code system, SNOMED is vast. As of its last release, it has about 360,000 concepts. You can access it from its web interface and explore exactly how many codes there are available. There's 33 different types of coffee listed. There are codes for forgetting your wedding anniversary, and there's even multiple ways to die in space. These are all medically relevant. Forgetting anniversaries can be an indicator of Alzheimer's. Types of coffee are relevant to diet and nutrition. And whether external or internal, a code must exist within a code system to be valid. In addition, the display value associated with the code should also be correct. There are unique circumstances in which a bad display name can be downgraded from an error to a warning, but we're going to pretend for now that we live in a perfect world, and we're going to assume that the display value always needs to be correct. For external systems, it's tempting to think that LOINC or SNOMED are queried directly, but this is not the case. For large external code systems, the validator will use the FHIR API for validating terminology, and it will use a FHIR terminology server to do that, not directly going to LOINC or SNOMED. The default server for the Validator CLI is tx.phir.org. The server is loaded with SNOMED, LOINC, and more commonly used terminologies. The validator can also be pointed to any compliant FHIR server. I will touch briefly on that later. If the default server is down, you will likely run into issues trying to validate resources. You'll get exceptions that clearly state that the server could not be contacted. If that's the case, there's a Zulip channel dedicated to terminology, listed here and also in the tinyURL links. There's where you can raise the issue and someone will investigate why the server is down and will bring it back up again. A lot of times this might not actually happen because we use cached terminology results in the application, but if you're doing something that is fresh and new, you might run into this error if the server is down. In addition to code systems, FHIR also uses the concept of value sets to limit the codes that are valid in a particular context. For example, it doesn't make sense to use a code for Arabian coffee for a property representing an anatomical body site. To prevent this, the body site value set exists. This value set restricts the allowable codes to a smaller set of SNOMED codes. So to be valid, the code must belong to the value set and must also be a valid code within its code system. And there are numerous value sets available within FHIR and within implementation guides. This isn't just body site is the only one. So I think that's about as far as we're going to get into code and codable concept with regards to validation. There's still 3 more aspects to go through, and then I'll do a quick recap of all of them. So moving on, invariants. Invariants are constraints on a property that must be satisfied. You can find invariants listed in the description and constraints column of the resource structure table. They're defined in human-readable prose, and more importantly for our purposes, they're also defined in machine-readable terms. An example of an invariant is the patient contact property. If you click on the patient contact property, you'll be taken to its details, which will list its invariants. The rule for this invariant states that a contact must contain a contact's details or reference an organization. To be able to determine whether or not this invariant is satisfied, the validator will use the provided FHIR path expression. FHIR path is an expression language used in FHIR related to specifications, and it can be quite complex. There will be another presentation in this series on October 29th, which focuses on FHIR Path Lab. I will be personally tuning into that. But for this presentation, the only thing we need to know is that FHIR path can be used to evaluate logical expressions based on resources. In this case, the FHIR path expression is specifying that the invariant is true if a patient contact's name, telecom, address, or organization properties exist in that resource. If this does not resolve to true, the invariant will be invalid. If it resolves to true, then the invariant is valid, and at least that part of the resource is correct. Profiles. You might have heard this before. FHIR lives by the 80-20 rule, where the FHIR core specification should ideally cover 80% of the average user's needs. It is not designed to be all things to all people. Use cases vary depending on jurisdictions, domains, and various functional approaches. So in most cases, the FHIR specification needs more flexibility, and this is generally done through implementation guides. An implementation guide describes how FHIR resources can be utilized for a particular use case. It can also contain resource profiles, which are resource specifications that differ from the base FHIR spec. This is used to make resources work for a particular use case. Officially supported IGs can be browsed here in the FHIR Packages Registry, and also here in the Simplifier Packages Registry. Again, all these links available in the tinyURL. One of the most popular implementation guides is the US Core. We can see a patient profile from that guide here. For each profile, you will see a differential table. which is similar to a structure table, which will give you a basic overview of how the properties of a resource change for that profile. A good example of some of these differences in the US core patient spec is gender, which is normally a 0 to 1 cardinality in the base spec, meaning it can exist or it should only have one entry, but it has a required cardinality of 1 in the US core IG. There are also some new properties available that don't exist at all in the base specification: US core race, US core ethnicity, and US core birth sex. New properties such as these are defined by a FHIR concept known as extensions. When you are validating, there are a number of ways to supply the validator with an IG or a set of IGs. When profiles from those IGs are specified, the validator will ensure that your resource conforms to all of them. In a second, I'll have a quick drink here. The last aspect applies specifically to questionnaire response resources. A questionnaire response may or may not have an associated questionnaire. If it does have an associated questionnaire resource, the validator will verify that each item in the response is correct for the corresponding item in the questionnaire. There are multiple aspects that need to be satisfied, like correct response type, length constraints, value sets for responses, etc., etc. The questionnaire specification will give details on those aspects. If you want to associate a questionnaire with a resource, you will do so using a similar process to implementation guides. So to recap, a valid resource is one that satisfies all 7 of these aspects for validity: structure, cardinality, value domains, coding and codable concept bindings, invariants, profiles, and questionnaires. Now that we understand the basics of validation and have seen a trivial validation workflow, we're going to take a look at some features that will allow us to accomplish some common validation tasks. Like most command line tools, if you provide no parameters to the tool or provide a -help parameter, it will output a help page. This help page will list all available parameters and will provide some descriptions on how to use them. More detailed documentation, including examples, can be found on the Confluence page, maintained by Graham and myself and the FHIR community. The logic of validation itself, which is what I just went through, is documented in its own specification. And if you're evaluating what a resource requires in order to be valid, this can be an invaluable resource. These are some of the more common features of validation that we might want to set. We might want to set the resources we want to validate, the FHIR version we want to validate against, any implementation guides we want to validate against, and terminology services that we might want to use to validate codes and codable concepts. We will need to specify the resource or resources that you are validating. Aside from specifying a single file, as I showed earlier, you can specify multiple files. You can specify all the files within a directory. You can specify files matching a pattern, and you can even use URLs, which the validator will attempt to automatically resolve. The validator will try to infer the format of the resource automatically, using either the file extension or the file content itself. By default, the validator will use version R5 of the FHIR specification. Since not everyone is using R5, you can also manually specify a particular version. You can see a list of which versions are available by running the CLI in help mode, as I mentioned earlier. Implementation guides and profiles. If you're validating against particular profiles, you will likely need to include an implementation guide that supplies them. Officially supported IGs can be referenced by name and version. The validator will attempt to download these from either of the previously mentioned package servers. If you leave out the version, it will default to the latest version. And you can also specify an IG directly by URL. There are other more advanced options. You can use the contents of a directory or a downloaded or locally generated TGZ package file. These options are useful if you're an implementation guide author or you're testing with a guide that is still under development. Once you have your implementation guide, you then specify the profile or profiles that you want to validate against using their canonical URLs. As I mentioned previously, the default terminology server is not necessarily the only terminology server available. You can also validate your resource against whatever server you want, as long as that server conforms to FHIR terminology server requirements. To date, OntoServer is the only such server available. I am hoping that there will be more available in the future, and that link, of course, will be contained in the tiny URL. The Validator CLI also has a lot of functionality outside of just validating resources. As I mentioned before, the validator code is just one part of the tooling that Graham and others use to publish the base FHIR specification, to build and test implementation guides, and to provide a variety of other useful functionality. A lot of these tasks are also available in the Validator CLI. The most basic ones are here, and I'll just give a brief description of what each one does. Compare produces comparisons between resource specifications from different IGs. Convert converts resources from one format to another, for example, from XML to JSON, from JSON to Turtle, etc., etc. FHIRPath evaluates FHIR expressions on a resource or on a logical model. Narrative generates a narrative for a resource. Snapshot generates a snapshot of a profile. Tests runs the validator against a series of test cases. If you're a contributor to the validator logic, this is a useful way to quickly create new test cases that capture specific validation results. Transform uses a FHIR resource called a structure map to transform from one structure to another. And ToVersion converts FHIR resources between different versions of FHIR. I mentioned before that the validation code is actually used in a number of different projects. Another open source project that uses it is the Web Validator, accessible at validator.phir.org. It differs from the command line interface by being accessible through a web user interface. In the background, there's a server actually validating resources using the core validator. All you need to interact with it is a modern web browser, which will direct to validator.phir.org. The Web Validator offers a bit more user-friendliness, but it comes with a few trade-offs, which I'll explain as we go over how to use the application. Your usual entry point to the validator is this page, which allows you to cut and paste FHIR resources into the code editor panel. You could write a resource out by hand if you really wanted. An important thing to note is that when you are using the Web Validator, you are sending your data to our server. Do not send us personal health information or confidential information. We do not store any resources on the host machine, but it's just good practice not to send these types of data. If you need to validate this kind of data, you should be using the Validator CLI, or you should be following the documented process for hosting your own version of the Web Validator, which I'll go into very briefly later. Assuming for now that we're using the public Web Validator, we can paste or manually enter a resource in either JSON or XML format. Once a resource is entered, you scroll down until you can see the Validate button. Then you press it. The server will run your validation and you'll get a split screen. On one side, you'll see the resource you entered, and on the other, you'll see a list of validation issues. If you click on an issue, the line it appears in will automatically be highlighted, and you will automatically scroll to that line. This is a vast improvement on having to switch back and forth between the results and a file in another editor using the CLI. You can also use the set of toggle switches above the result panels to only show a specific severity of issue. If you're only interested in errors or warnings, you can switch off all other severities and just focus on those. To speed up the user experience, the Web Validator also has several preloaded validation types. These were requested by the FHIR community, and they include several types of IPS document, CDA and CCDA documents, and SQL and FHIR documents, as well as a default R5 resource setting. The reason for these preset validation types is twofold. Since these types of validation are high in demand, it saves the user from having to manually configure them. They are also bound to preloaded validation engines. A lot of validation time is not spent actually performing validation logic, but in loading all the conformance resources. In some cases, even on fast machines, this can take several minutes, which is a terrible response time for a web application. So these preloaded engines are always available on the server with all of their resources already loaded, so validation runs much quicker. If those presets do not fulfill your needs, you can click on the Options tab in the interface. Most of the necessary CLI options are available, but not all, and these are all limited just to tasks pertaining to validation. There is no ability to convert between file types, develop narratives, etc., etc. The options page offers inline documentation for all of its options and links out to other documentation when necessary. So I won't be going into details on individual options during this presentation. Another optimization the online validator provides is the ability to upload multiple files for validation. To do this, you click on the Upload Resources tab in the main Validate interface. You select files from your computer to be uploaded. Then you click on Validate, and when your files are validated, they will appear with an appropriate symbol telling you quickly if they are valid or not. Clicking on an individual file will reveal details about the validation issues with the same interface as the manual entry we saw earlier. Hosting the Web Validator. If you want to host your own version of the Web Validator, it's distributed as a Docker image downloadable from Docker Hub. This is a good option if you need to validate PHI, but want the convenience of the web interface. There's a thorough guide on how to set up a machine to run this Docker image on the documentation website. If anyone out there is doing this or is interested in doing this, I'd love to hear your experiences. The core validation code also shows up in use in a few other projects. The IG Publisher, HAPI-FHIR, and Inferno are some examples. The IG Publisher, or the Implementation Guide Publisher, is a part of the tooling that Graham and I maintain, and it uses the core validation code to ensure that package resources are valid. This is advantageous to know if you're developing an IG, because it means that you can use the validator directly to validate your resources instead of having to debug an entire implementation guide all at once. HAPI-FHIR. HAPI-FHIR uses the core code in a number of places. It uses the Java resource models provided by the core, the FHIR path evaluator, and of course the validator code. Using this feature of HAPI-FHIR has its own documentation page listed here. Inferno. For some time now, the Inferno validator has been using the validator wrapper as a backend for its project. So our server is actually their server. This has been a good exercise and thus far has shaken out some bugs and shortcomings that we've been able to improve upon. And if you're interested in using the validation code in your own projects, the best place to start is in the core library README. This is available on the landing page of the GitHub project, and it will get you started with all the necessary build and import information. There's also a dedicated project that I started, which works through several examples of using the library in a Java project. If you'd like to help out with the development of the core libraries, we encourage you to report bugs, suggest features, and contribute code through pull requests. There's also a vast community of FHIR specification developers, implementers, and tooling developers on Zulip, so please ask questions and start discussions there as well. And that brings us to the end of this presentation. I'd like to thank HL7 and the Assistant Secretary for Technology Policy for their financial support for the development of these projects. And of course, thank you to all for attending.
Thanks for watching. If you found this helpful, give us a like, subscribe, and hit the bell so you won't miss the next one.